Hi. This session is on regression coefficients and standard error of estimates. Regression coefficients and standard error of estimates both are the part of regression analysis, right? Uh, what we'll do is we had solved a numerical problem in our last lecture of regression analysis, simple regression, right? Now, actually, we are interested to learn what is regression coefficient, right? So we are not calculating once again the regression equation, but we assume that we have been given the values, right? The x and y, and we know how to calculate these values, right? And finally, we have published two equations, that is y on x and x on y. Now we are more interested for regression coefficient, right? So look into the regression line equation y on x. It says y minus y bar equals to r sigma y by sigma x in bracket x minus x bar. So this part r sigma y by sigma x collectively called as regression coefficient. Similarly, for regression line y on x, this part r sigma x by sigma y is collectively known as regression coefficient, right? So we'll go to the formula of this thing. See, r sigma y by sigma x is one of our regression coefficient, which is named as byx. This is the notation for regression coefficient. Now, once you write byx, it means this is the regression coefficient for the equation y on x. Another regression coefficient is bxy. That means it is the regression coefficient for x on y, and this is the formula, right? So we will only calculate these regression coefficients. So b of yx equals to b of yx equals to, see, this is r. We'll see the value of r from here. Our r is 0.27, right? So it is 0.27, right, into sigma y upon sigma x. Let us see what was our sigma y. Our sigma y was 3.41 and sigma x 5.80. So 3.41 divided by 5.80, right? So calculate 0.27 into 0.27 into 0.59, as if we divide these two, right, we'll get 0.59. Fine. So finally it is 0.27 into 0.59. So 0.16. That means the value of regression coefficient y on x, that is byx, is equal to 0.16. Now let us calculate bxy. So bxy equals to r is 0.27 into, now the ratio is reversed, sigma x upon sigma y. This is our sigma x 5.8 divided by, this is our sigma y 3.41. So it is 0.27 into 5.8 divided by 3.41. So it is 1.7. Therefore, the value of b of xy is 0.46. Correct? That is 0.46. Now, we'll see few properties of these regression coefficients. One property is, if you want to get correlation coefficient from regression coefficients, then the formula says r equals to square root of b of yx into b of xy. So b of yx for us is 0.16 into b of xy for us is 0.46, right? So therefore it is the square root of 0.16 into 0.46, so 0.073, 0.073. So 0.073 square root is 0.27, right? So we got back our r, correct? One more property is, both the regression coefficients will have same sign. Same sign means, if b of ix is positive, see b of xy is also positive. If b of yx turns up as negative, b of xy also has to turn up as negative only. They cannot have different signs, right? And whatever their sign is, that will be the sign of the regression coefficient also. Sorry, correlation coefficient also, correct? So both the regression coefficients will have same signs, and the sign they have, the same sign will be mapped to the correlation coefficient as well. Fine. Chalo. So now let us try to understand standard error of estimate, or let us try to calculate standard error of estimate. What we'll do is, we'll try for regression line y on x, and we have assumed that our y is the dependent variable, correct? And this is the formula. This is the equation we have derived, right? I'm writing this equation here. It's y on x. What is that? Y on x is, this is the formula we have. So based on this, we are calculating ye, which is the estimated, y estimated, right? Now how to get y estimated? Let us even copy our x. I'll put it is here, and this is our ye. Fine. Now see, what happens is, if I put 30 in this equation, right? So this equation will become, this equation will become, or let me do one thing. Let me take these things here. So I can write, for x equals to 30, what will be the estimated y from this equation, right? One, we have an actual y, right? Another one is estimated y. Now see, if I put x here, then our y e will be will be 0.17 into, instead of x it will be 30 plus 53.6, right? Likewise, for everything we have, I'm just calculating the value here, y, right? So let me devise a formula. It's equal to 0.17 into the value of x. Let me put this thing into a bracket, and plus 53.6. See, as per this equation which we have derived, this should be our y, right? So this is called estimated. But what is our actual? Actual is 56, right? Likewise, I can have estimated value for all, right? For everything, for every value, put 44 as x, put 45 as x, put 43, 34, and 44, and you will get these values, right? So I'm just eliminating this part. Now see, we need to get the standard error of estimate, right? Now this y is our actual value and this is our estimated value. So we are calculating y minus ye, right? That means what is the difference between what we actually have and what we should have had, correct? So it's y minus ye, and this is for all the values, right? Finally, we'll calculate y minus ye whole square. Y minus ye whole square. Right. So we know y minus ye is this, right? So we'll get the square of this value. That means minus 2.7 into minus 2.7. So likewise, square of, now get the sum of this. So it is 65.91. Now I'll calculate here only. So sigma estimated is equal to, it is square root of summation y minus ye whole square. So y minus ye whole square is 65.91. So it is 65.91 divided by how many observations do we have? 1, 2, 3, 4, 5, 6. So it is 6 observations, right? So it is square root of, now 65.91 divided by 6 is 10.98. Therefore, sigma estimated is square root 10.98 square root. It is 3.3. So standard error of estimate is 3.3. Right? So in this session, we tried to discuss two things, that is regression coefficients. Regression coefficients are of two types, Vyx and Vxy. These are the formula. They have some properties, like if you want to get back your correlation coefficient, then get the product of both the coefficients and get square root. Next, uh, next is both the regression coefficients will have same sign. They cannot keep different signs, and the sign they have, that will be the sign of the correlation coefficient as well. Next, standard error. Standard error of estimate, you have to calculate the estimated dependent variable. If y is dependent, get dependent y, estimated y. If x is dependent, get estimated x, right? Now, whatever variable you are getting in estimation, get the deviation, then square, and finally you have the formula, right? So hope you have understood the concept. For any further query, mail me on the mentioned email ID, right? Thank you.